Today we are going to be factoring trinomials, and they'll be in the same form they were on previous lessons, where we have a coefficient in front of the x squared term. So it's an ax squared, and now the b term could be either positive or negative, and the c term will be either positive or negative. And so what makes these problems more difficult than the last type is that a is not necessarily going to be prime now. Notice how we have a 4, here we have a 9 and a 15, negative 15 actually. We'll see what we do with that one. And so in the past we always had this a term as prime, so we could always start off with that number and its opposite, and that number and x. And so here these problems are going to be a little bit more challenging. So we still do the first thing. Our first thing is to always look at this last digit's sign. And so the c term is negative. And so what that tells us is that their outer and inner terms are going to end up subtracting. We don't know which one's negative, but one of those, either the outer or the inner, are going to be negative. One of them will be, and they will make a 4x. So what that tells us is that the numbers, the outer terms and inner terms, are only 4 apart. And so when we do that, since they're only 4 apart, my guess is that I'm going to end up having to break this 4x squared down to 2x and x. The reason I would do that is because if I left it as 4x and 1x, when I multiply 4 times a number, one of the factors of 15, it's going to give me a number that's further apart than 4, I'm thinking, than when I multiply the inner terms together. So this is just a guess, and if it doesn't work, then we'll try some different factors of 4. So I just go ahead and come up with the different factors of 15. So I know 3 and 5, 5 and 3. And actually, since I've got the same number in front of the coefficient in front of the x term, actually the 5 and the 3 is going to give me the same answer. So this will be a little bit easier, so I don't have to try as many different possibilities here. So I've got 3 and 5 and 1 and 15. Let's try those. See which one, see if any of them work. So I'll try 3 and 5 first. And so when I do this, you see here I get 10x, and here I get 6x. And sure enough, those do subtract to make 4x. So I got it. I got 4x. Now I wanted a positive 4. So what that tells me is that I need more positives than I need negatives. So I need the 10 to be positive. So we're going to put the plus sign with the 5, the minus sign with the 3 to make it a negative 6x. We already know negative 3 and 5 make the negative 15x, or negative 15, and 2x make the 4x squared. So we know we have it right. So we can go ahead and write that in our answer box. 2x minus 3, and we have a 2x plus 5. Well, let's take a look at the next one. Again, the same sort of thing. The first 3 problems are going to be ones where our last term is negative. So let's take a look at it. Outer and inner are going to end up subtracting to make a positive 6x. And so when we go ahead and do this, we're going to draw our 2 sets of parentheses. And since they only are 6 units apart, my guess is that we need to break the 9 down. See, if we had 9 and 1, that would mean 9 times a number, and then the 1 times a number only need to be 6 apart. It seems that would be difficult to do. So I'm going to go ahead and try 3x and 3x. It's just a guess. I don't know if it's right or not. And now I can try the different factors of 8. And so since, again, 3 and 3 are the same number, I can just do one set. I don't have to do 4 and 2 and 2 and 4 because they'll give me the same answer. Now, if neither of these possibilities work, then I'm going to go with 9x and 1x. This is just our starting point. So now we're checking the outside terms and inside terms. So we'll put a 4 and a 2 in here, and we check these. Outside terms make 6x. The inside terms make 12x. And when I do subtract those, I do get a 6x. Now, I want a positive 6x. So that tells me that I need more positives than negatives. So minus sign with the 6, positive sign with the 12. So 4 needs to be positive. The negative 2 and the 3x make the negative 6x. And so that's how it works. And so again, it's always good to make sure that you understand that the last terms need to multiply to make negative 8, which they do. 3x and 3x multiply to make that 9x squared, which they do. And so we have it, 3x plus 4 multiplied by a 3x minus 2. Well, let's take a look at this next one here. What's different about this is that our first term is negative, and we don't typically have the first term as negative. You could factor it this way, but I tend to like to use my rule of looking at that last digit sign. And whenever I look at that last digit sign, I'm assuming the first digit is positive. So what I'm going to end up doing is I'm going to end up factoring out a -1. And so what that -1 is going to do is just stay on the outside of the parenthesis, and I'm going to end up with a 15x squared minus a 19x minus a 10. And now I'm going to go ahead and use my rule. And again, my rule is that I look at that last digit sign right here, and it's negative, and so I'm going to end up subtracting the outer terms and inner terms. And when I do that, I'm going to get a -19x. So that -1 just kind of hangs out at the end of the problem. We'll just kind of bring it down as we go. Now again, you could have left it in the problem and just dealt with the problem with the -15x squared, but I typically don't do that because I use this rule of looking at the last digit sign. And so when I go ahead and solve from here, I'm going to go ahead and draw my two sets of parentheses. Now, I need to get the two numbers to be 19 apart. Again, I'm not going to use 15x and x because I'm thinking 15 times a number is going to give me something a lot bigger than 19. I need a number bigger than 19, but not that much bigger. So I'm guessing it's going to be a 3x and a 5x first. Now again, I could be wrong, and if I'm wrong, then I would erase it, and I would just go with 15 and 1. But I think this is going to end up working. We'll see. So I need to now try the different factors of 10. Now here I need to try the different arrangements to make 10 because I do not have the same coefficient in front of the variable in that first term. So I'm going to be doing 2 and 5, 5 and 2, 10 and 1, and 1 and 10. So let's go ahead and try it. So I've got the 2 here and the 5 here first, and when I check those outside terms, I only get 15. That's kind of discouraging because in order to make them subtract to make 19, I need it to get to be bigger than 19. And you see, this only makes 10, and those subtract to make 5, so well short of where I needed it to be. So when I think about this now, I need to make sure I get that, probably the 5, to multiply by a number that will make it bigger than 19. So let's try this again. Let's try a 5 here. So I know 2 and 5 didn't work in that arrangement. So let's try 5 and 2. 5 first, 2 second. And this is a little bit more encouraging because you see how 5 and 5 make 25, and that is bigger than 19. 3 and 2 multiply to make 6, and those do subtract to make 19. So it works. Now, we want a -19, so that tells us that we need more negatives than positives. So we put the minus sign with the 25, which would make it this -5 here by the 5x makes the -25x. 3x and positive 2x make the 6x. And so now we've got our answer. We can go ahead and write that in our answer box. 3x minus 5 multiplied by a 5x plus 2. And again, you always check those outside. We know the outside and inside terms work, but you know the -5 and 2 make the -10. The 3x and the 5x make the 15x squared. And again, since we had that negative sign on the outside there, let's go ahead and reissue it right next to the one of those factors so that when we multiply everything out, we get the original problem. All right, well, let's take a look at the next one here. Here, we do not have the minus sign as the first sign. And these are easier problems because now we know the sign. And here's how we know it. We know that the outer terms and inner terms are now adding because they're the same sign. They add to make a positive 31x. So that tells us both signs need to be positive. So that's something that we can write in there right away. And then from there, now we need to start thinking of numbers that are going to end up multiplying to make 20, but then also multiplying to make 12x. Now, since I have two numbers, the outside and inside terms need to add to make 31. I want them to be smaller than 31. So I think I need to break the 12x down to 3x and 4x, probably as small as I can get them, because if I did 12 and 1, 12 times a number is going to probably give me something bigger than 31. 6 times 2 also makes 12x squared, but 6 times in numbers is going to give me something typically bigger than 31. So I want these numbers to be a little smaller, so I'm picking smaller numbers that multiply to make 12. Now my guess is that I need to break the 20 down to 5 and 4, or it could be 4 and 5. I could also have 2 and 10, 10 and 2, I have 1 and 20 and 20 and 1. So I have all these different options, but I think it's probably going to be one of these up here. And I just try them and see which one ends up working. If none of them work, then I need to rethink my 12x squared. I need to come up with different numbers that multiply to make it. So let's see if I got it here. 20x and 12x. Nope. Doesn't look like those add to make 31. Very close, but just not quite there. It makes 32. So I know this is not right, so I move on to the next one. Let's go ahead and erase that. And let's try the next set. So now we'll try the 4 and the 5 here. See what this ends up making. We got 16x. And here we get 15x, and sure enough, those do end up working. So 31x. So we got it on the second try there. Again, the reason I came up with or tried those numbers first is just thinking about what multiplies to make a number that's smaller than 30. And I knew 6 times 5 makes 30, and I wanted it to be smaller than 30, which 31, but 30 is smaller than 31, but I knew I didn't want it that close to 31. Let's move on to the next one. Here we have an 8x squared and then minus a 29x plus 15. So the first thing I'm looking at is that last digit sign, and since it's positive, it tells me outer and inner are adding together, and they're this time going to make a negative 29x, so that tells me both signs are negative. So we'll go ahead and just start by drawing the two sets of parentheses. We'll put in the minus sign, and we now know that they have to multiply to make well, the outside and inside terms are adding to make 29. So I'm guessing it's 4x and 2x. I'm thinking that I need to only multiply 4 by a number, and that's going to get me something pretty close to that 29. So we go ahead and try some different factors of 15, 3 and 5, 5 and 3, 1, 15, 15, 1, and we see which one ends up working. But maybe none of them are going to work, which in that case, then I'd change the 4x and the 2x to 8 and 1. So let's try this first one here. The 4 times the 5 makes 20. And these numbers only make 6, so it didn't quite work out. And so what we have to do is go ahead and erase those and try something else. And so again, you don't always get on the first try, but you keep on trying till it ends up working. So we take a look at the next one, and we cross this one off. Let's try the 5 and the 3 here. See, this makes 12, and this makes 10, and those only add to make 22. So not quite working that time, so we got to try something else. And so when I look at these numbers, I'm thinking, okay, when I multiply 15 times 1, that's way bigger, and 15 times 2 is even bigger. So I know it's not these other two. So what that tells me is that I need to try something different. So now that I've determined that it's not going to end up being 4x and the 2x, I need to erase that. So again, I thought it might have been that to start with, but I was wrong, so I have to try something else. So I'm going to retry these same numbers here, but this time I'm putting in the 8x and the 1x. And so let's go back to these numbers. So we got 3 and 5, and I got 5 and 3. And I'm going to go ahead and try this 5 and 3 first. And so let's see if this works. Here are the outside terms make 24, inside make 5x, and I do get those add to make the 29x, so it does end up working out. So we got an x minus 5 and an x minus 3. Well, the last problem is nice because the last term is a prime number. And it's also positive, so it tells us the outer and inner are adding to make 23x. So when I start this, instead of starting with numbers that multiply to make 6, I'm starting with the 7 and the 1, and I know both signs are positive. So now I just need to figure out, is it going to end up being a 2x and a 3x, or is it going to be 3x and 2x, or is it going to be a 6x and a 1x, or is it going to be a 1x and a 6x? And so I just try different options that end up, I thinking, work. And so let's go ahead and we'll try this first one, 2x and 3x. You see, when I check those outside terms, they make a 2x. The inside make 21x, and it does add to make 23x. So it works, and we got it. And so 2x plus 7 and a 2x or a 3x plus 1. Good luck on tonight's homework.